So now we're going to talk about what we call rationalizing the denominator. Now, the reason we rationalize the denominators, it may not seem like it, but it's easier to divide, it's easier to simplify. So back in the day, before calculators were invented, they actually had to divide these in by hand, right? And so to put it simpler, let me do this. Actually, let's just look at this first one, right? So when we rationalize the denominator, it's a process, and the process is we want to get rid of the square root in the denominator, right? So let's see, get rid of square root in denominator. Okay, which brings the question, how do you do that? So in here, we're only going to work with single numbers, but once you get past this, you're going to do what's eventually going to call, you're going to multiply what we call the conjugate. Now, here, don't have to worry about it, but let's just take a look at what this is, right? So, to get rid of the square root, we don't want to change the actual value, right? So we don't want it, like, for example, if that was 2, we don't want to change it to 4 or 3 or anything like that, right? So the best thing to do is multiply by 1, because if you multiply by 1, it's not really doing anything, right? But if I multiply by literally the number 1, that doesn't do anything for us. Instead, I'm going to multiply by the square root of 5 over the square root of 5. In other words, that's still 1, right? Because square root of 5 over square root of 5 is 1. But in this case, I'm multiplying by something that's going to help me move things around, right? So the reason I'm doing this is because if I were to multiply, remember, we just multiply right across. On the numerator on the top, we get 4 times the square root of 5. In the denominator at the bottom, when we multiply these two, let's see what happens, right? So that would become the square root of 25. But then if we break that down, that's 5 times 5, right? And so that pair of 5s means I can bring that 5 outside and there's nothing left inside. So that actually goes down to 4 square roots of 5 over 5, okay? So I know what you're thinking, and you're saying, how is that any simpler than that, right? So if we think about it, the square root of 5 is around 2 point something, right? 2 point plus a number. But 5, that's just 5, right? There's no decimals to it. Now, if you remember how division works, right? So let's say we have 2 divided by 3. That would look like 2 being divided by 3, right? Now that's pretty simple, but now once you start doing 2 point something with decimal numbers divided by a whole number, now we're getting into some trouble, because now you gotta figure out how many decimals do you carry, how many, etc., right? But if you flip it the other way, so if we say 5 divided by, now when we multiply, that's just 8 point something, right? Now that's a little bit easier to manage, because on the out here we don't really have to worry about the decimals. Now we have to worry about the decimals in there, right? So if you don't remember division, go back, look at it. Okay, so that's one of the reasons we rationalize the denominator. And again, when you get to calculus, or when you get to pre-cal, you're gonna have, or algebra 2, I believe, you're gonna have to do what you call the conjugate, which is basically the same thing, just with addition or subtraction between them, right? So here's my second problem. If I want to rationalize the denominator, which means I want to get rid of the square root at the bottom, I multiply the top and the bottom by the square root that I have, or the square root that I'm trying to cancel, right? So once again, and we multiply straight across. So on the top, I have 5 times 3, which gives me the square root of 15. And at the bottom, I'm going to have, let's kind of work it out here, right? So this becomes, well, put it this way, I don't really care about this number, because the two numbers that are multiplied to get that number are here, which is 3 and 3. That gives me a pair and nothing's left over, and that comes outside. So here I'm left with 3. Now here's a just a regular rational number, and here is an irrational number because it's inside a square root. So even though 15 divides by 3, that 15 is inside the square root. So it's not really 15, it's some decimal, right? And so we cannot simplify those two because one is a square root, one is a number. So in this case, this is as far as we can take it. And even if I wanted to break down the square root of 15, there's no pairs inside it because the two numbers are 3 and 5. And so here, that's as simplest as it gets.